Hi, I'm Larry Bucket, the DCC guy. If you want Keep Alive lighting for your cabooses and passenger cars like this, stick around for the video. I want to ask you to take a second to subscribe. Click on the subscribe box, and when that comes up, click on the little bell right next to it and click all. That way you'll be notified every time that I upload a new video. Okay, let's go ahead and get started. You know, back in video 101, I showed you how to build a lighting stay alive or keep alive for this particular caboose. And, you know, it was a little bit big. It used a fairly large 1,000 microfarad capacitor to keep alive the lights. And, you know, it was a clunky thing that you had to solder together and you know, squeeze into your cars. So what I've done is I went ahead and, as I promised in that video or after that video, I've put together a new circuit for you that is smaller, fewer components, and goes together a lot more straightforward, at least I feel. And I know it's going to fit inside of your HO equipment. I can't guarantee about your in-scale stuff. I just don't have any in-scale passenger cars or cabooses to work with. I'm going to zoom in down here on the workbench, and we'll take a look at the components to this circuit and how they go together and work. So let's get started. In video 101, where I showed you how to make the first Keep Alive circuit, I used this round bridge rectifier here, and a resistor and a trim pot, and this large 1,000 microfarad capacitor. Now, this was the problem for a lot of people because they didn't feel that it was going to fit in scale and possibly some other types of situations. So I wanted to find something that was going to be smaller than this guy here, and that seemed to be the big limitation. So what I did was, let's move these out of the way. If you remember in the video I did on 5 new gadgets for your model railroad, I showed you this little device here. It's called a let me get it up here so you can see it. It's called a buckboard. And what it does is it takes DC voltage in here at somewhere between 4.75, I believe, and 23 volts. And then at this end here, it has output contacts that will give you something between 1 and 17 volts DC output. Now, it's fairly easy to solder to. Here on the back, you can see we have a plus in and a minus in. And then we have an arrow that points in this direction, which is the direction that current flows. So power comes in here, and then it's going to go out this side. And at this end, we have a plus out and a minus out. So it's a very simple circuit. Now, how do you get your DC voltage for this? Well, in the previous circuit, I used this round full-wave bridge rectifier. However, for this one, I wanted something that was a little bit more compact. So I found this full-wave bridge rectifier here on the All Electronics website. And by the way, I will give you part numbers for a lot of this stuff. However, some things, like this one here, they're available on eBay. And I just, you know, you can just do a search on eBay for buckboard, and that will come up. And there are a number of different dealers that provide these. So, and they change from time to time. So it's not going to do me any good to give you a link to a dealer that's not going to be offering these in a month from now. So I'm just going to tell you, this is a buckboard. Do a search for it on eBay, and that's very simple to do. And you will see these. Now, I got this 10 of these for $6.95. So you're looking, and that included shipping. So you're looking at about 70 cents each for these. These are probably about a quarter each from All Electronics. And the expensive part I'll show you in a minute. So there are only 3 parts to this circuit, unlike the previous one. So if you look at this little guy here, you've got these 2 terminals here with the little squiggly lines. That's for your AC power. And that also is for DC power, so because it's a type of AC, it's an alternating current. And then this is your plus and minus terminals out. Okay, so this would go to the track. This goes to your buckboard. That provides your power source. Okay, and it's just got these little 4 legs here, and you can solder these directly to this board. Now, as I showed you a minute ago, this here has the positive in and the negative in. So all you need to do is match up the positive and negative legs on this guy and connect them to the positive and negative input terminals on your buckboard. Then the next part is this little guy here. Now this is a super capacitor. I used this in one of the locomotive keep alives that I did in a video a long time ago, and I'll put a link to that up here above me on the left. And what you'll see here then is this is a 3 volt 1 farad. Okay, so this one here, the big one that I showed you a minute ago, that's 1,000 microfarads. And 16 volts or 25, it doesn't matter. And this one here is a 3 volt 1 farad. So smaller voltage, but a lot more storage capacity at that voltage. Okay, so it's the difference between keeping something alive a little while or not. Now, why did I go with a 3 volt capacitor as opposed to the 16 or 25? Well, once you start getting into higher voltage values for these supercapacitors, they get big. So a 5 volt would be about the same size as this one. So there would be no point in going to a different supercapacitor. These are more expensive. These are going to run you about $1.50, $1.60 each in quantities of 10. If you buy one, it's going to cost you maybe $2 each. So you've got maybe a quarter for this, 70 cents for this, and somewhere between $1.50 and $2 for the little keep alive. So you're talking about, what, $3, something like that, to make this circuit right here. And that's all it is. You don't need any other components to go with this. Okay, so how does this go together? Let me show you that. So this is a built-up circuit right here. I've taken the little bridge rectifier and I've soldered the positive and the negative legs here to the input side here. Okay, and so we've got whatever voltage coming in from your DCC system. It's probably going to be somewhere around 13 volts because you're going to lose a half to 1.5 volts coming through the bridge rectifier from your DCC track. So if you're at about 14 volts, then you're going to be somewhere around 13 into it. Now, this is the output side. Okay, what I've done is I've simply soldered the wires, the little legs on the supercapacitor to the plus and minus output. Okay, now remember, on these capacitors there is a white stripe right here on the side indicating the negative leg. So this is the negative wire, the negative contact, and this one here would be your positive. So what I've done is I've soldered the negative to the negative out and the positive to the positive out. Okay? Now let me tell you something before you do that. Before you even attach this guy to the board, you need to set the voltage level output on this. And it's very easy to do. Right here, there is, and I'll see if I can show you that. Yeah, there it is. Right here, there is a little trim pot. Very tiny thing. Put your little screwdriver in there, and you can adjust the voltage by simply turning that. Now, as I remember, turning it to the right decreases the voltage. Turning it to the left increases the voltage. So I turn it all the way off, and then I will attach this to my DCC power source, okay? And I will attach voltmeter leads to my positive and my negative terminals, like so. Turn on my voltmeter on DC voltage, and then I will adjust the output voltage to just under 3 volts. Now, why 3 volts? Well, there's 2 reasons. First off, this little supercapacitor is rated at 3 volts, as I said earlier. If you supply more than 3 volts, you are going to turn this into a smoke generator real quick. okay, because it won't take it. It will explode or it will fail otherwise. But it's not going to take more than 3 volts for very long. So that's why you have to adjust this up front, then add the supercapacitor. Don't do that first. Adjust the voltage to under 3 volts, say 2.9, 2.95, and then solder on the supercapacitor. And that way it's safe. The other reason for using a 3 volt is LEDs like these two here are rated at somewhere around 3 volts DC. Okay? Now they're at about 20 milliamps each, and they will come on somewhere between 2.5 and 3, and they're going to blow up once you get much above 3.5. Okay, so they're going to be super bright. So a nice brightness comes at about 3 volts. You can use the 3 millimeter LED package, or you can use these little surface mount LEDs that I've been using for my headlights for a long time. And again, you can get these on eBay. Now, I know for a fact that NCE, TCS, Soundtrax, and Digitrax all sell packages of these little golden white LEDs. And if you do a search on eBay, you will see vendors come up selling all of those. Also, this little guy here, these are available on eBay. Do a search for golden white surface mount LEDs, and these will come up. Again, a number of different vendors have these, and just go with the cheapest one. I can't guarantee you that the one that I used is going to be there selling these next week, tomorrow, or even right now. So you're better off to do a search for golden white surface mount LEDs or 3 millimeter golden white LEDs. And that way you'll be able to find them on eBay. Also, if you go to Streamline Backshop, SBS4DCC.com, he sells them as well. So you can find those on that website. Most dealers who sell DCC accessories will have these listed for sale. So just check your favorite dealer or get them off of eBay. Okay. Now, as far as connecting these, it's very easy. Now, all you have to do is remember that on the 3 millimeter ones, the long leg here is positive, okay? Most of these will come with a longer leg that's positive. You can also take 2 1.5 volt AA batteries and connect them together and provide power to make sure that it works and to find out the plus and minus legs. And the same goes this guy here. These come with a 1000 ohm resistor, and in this circuit you'll have to cut this off, okay? Because you don't need that resistor on there. But again, this, on the ones that I have, the resistor is placed on the positive wire. So if you purchase these, then make sure that you check, because I can't guarantee that it is consistent from one manufacturer or one source to another. As far as connecting the LEDs to them, if you're just going to be lighting up a caboose or something like that, you can just simply connect these 2 wires on the LED directly to the legs like this here. I can simply bend these out a little bit, and you can solder the legs to the bottom of the board and then bend the LED up, and I'll show you one in a minute like that. You can also wire these up to the board, and you can use multiples of these, because this, as I said, this board here is rated at 1.8 amps continuous. Now each one of these little LEDs is rated at about 20 milliamps. So, you know, that's 50 per amp, okay? So you can power more of these little LEDs than you would want to fool with in a passenger car or a caboose. But it gives you the option of placing these where you want and running the wires without having to attach an LED directly to the board. But there are cases where that works very well as well, and I'll show you one in just a minute. Okay, so let me show you a board that I've put together with the LED on it, and we'll take a look at how it lights up. Okay, here's one of the completed circuits installed in a caboose. And you can see, as I showed you, it's just like this one right here. It's all wired together, soldered to the bottom here. And I just used some double-sided foam tape to hold it in place. And I've got my single LED connected to the contacts here adjacent to the capacitor. Okay, and this is the same caboose that I used back in 101, video 101. So I've got my power pickups coming from each one of the trucks down below, here and here, okay, providing power. And that feeds into my bridge rectifier, which provides the power to the buckboard, which provides the power to both the supercapacitor and the LED. So let's go ahead and I'll show you how that works. We'll zoom out a little bit for this, and I'm going to hook it up now to a power cap. So you can see we've got a very nice bright light. It's going to take a minute or two before this supercapacitor fully charges. But once it charges, it's going to give you a good keep alive as your cars roll down the track. Okay, so it's a good stable source of power. Now, I will point out, in the previous video, I showed how to use these strips of LEDs, and these work very well in that particular circuit. They will not work with this circuit because remember, this is a 3-volt supercapacitor. This requires 12 volts. So if you don't want the capacitance, you can take that off, set this for 12 volts, and you're good to go to power these. But you can't mix these. Okay, that's one of the limitations of this circuit. It is rated for just 3 volts. However, you can use multiple LEDs with this circuit. Also, you don't have to wire it together like I've done here. You can attach this to the board using wires, and the same thing over here with the supercapacitor and the LEDs. Everything can be wired up separate, or you can put it together as one combined neat little package like this. For HO scale, this is going to work great because, it gives you a good stable power source. I can lift it off the track and you can see it's holding its brightness quite nicely. It's got a slow die down just like a standard keep alive, and it's going to give you a good brightness, bright light for your rolling stock. And I think, this, you can easily fit this into just about all HO passenger cars. And cabooses, I would imagine it's going to fit in a lot of in-scale situations as well. The problem you might run into would be where you have an interior to deal with and have to work around that. And that's where wiring these individual components to the board will be better, because then you can fit this supercapacitor and the board and the bridge rectifier separately, and you can wire up your LEDs and put them wherever you want. Okay. There. Let's get this on here. It takes it takes a couple of minutes sometimes for this to fully charge, but once it's fully charged, it'll give you a good stable light. Okay, so that's this one, and again, you can see it's got a good hold-up time. Now, one question that people had in the follow-up comments was about these wipers. Now, I told you there in that video, I believe, that I got these from Richmond Controls, and they're listed on his website. I don't know the availability of those there. You can also get these from Streamline Backshop. I know that he has some of these in stock, not very many, and of different types. And he has it for 4-axle and 6-axle and in scale and HO scale and the like. So you just have to take a look at what he's got. And I talked with him, and he is in the process of getting more of these ordered. However, given the COVID-19 problem, it may not be quickly. Also, if you look on his website and do a search, he sells these in brass made by TCS. He sells a version made by ESU that are wheel wipers. So take a look and do some searches on his website and see what he has. You also can find wheel wipers and the like sometimes on eBay. So don't give up looking on eBay. Okay, now another option that I mentioned was purchasing the bronze sheet. Now this is a piece of phosphor spring bronze. And what that is, bronze is an alloy of copper, and in this case, phosphorus has been added to it. And that changes the characteristics somewhat, and it also imparts a certain springiness, apparently, because this will spring back. Whereas with brass, if you install brass wipers and they get overbent a little bit, they will not spring back into position in most cases. Bronze, spring bronze will. That's why it's called spring bronze. So if you buy a piece of this, and this is 0.005 inches thick, I found it with a simple search on eBay. Okay, that's the only place I could find it. What I did was I took it and I cut strips 3/8 inches wide and long enough to fit across the two axles. I then drilled a hole here for my screw that holds the truck in place. So we're going to have power picked up from the wipers, transmitted through the screw up into the body of the cab. Okay, and as I showed you in the previous video, how to set these wheels up so that you're picking up from opposite rails on each truck and providing different power. Okay, now this is what it looks like on the inside. Here I just took some scrap bronze and drilled a small hole, threaded it onto the top of each screw coming up from the trucks, and then soldered on a wire. And I ran a wire from each truck pickup to the AC terminals here on the bridge rectifier. And then that provides your positive and minus DC power to the buckboard, which lights up the LED. So hopefully that will answer your questions. You'll be able to find either the power pickups or the axle wipers on the Richmond Controls website or the Streamline Backshop website, or you'll be able to find some of the spring bronze and make your own the way I did. This is not cheap because it's hard to find anymore, and it will go a long way though. So you can make a lot of wheel wipers with a piece of spring bronze like this one. Okay. That's all I have today. So I hope that will work for you. Give it a try. And if you have any questions, let me know in the comments. I will be adding materials to the description for this video. And, hopefully by now, everybody that's using YouTube here knows how to access the description for each video. There is a written description for each video. And if you open those up, typically creators like myself add things to information like sources for the components that they mention in their videos. So if you don't know how to do that, do a search on YouTube for descriptions, and they will tell you how to access the descriptions. I will tell you though, if you are using a smart TV, or a television box like Roku to access YouTube, you will not be able to get the descriptions. Those are only available on cell phones, tablet computers, and desktop and laptop computer browser versions. The Roku app, for example, or the access will not give you access to the descriptions, unfortunately. Okay, that's all I've got for today. Well, that's the circuit that I came up with that hopefully will work better for you in your passenger cars and cabooses. It's smaller, it's easier to put together. It probably is just a little bit more expensive than my previous version, but it will do the job for you, and I think is a lot more flexible. So let me know what you think of it in the comment section, and have a great weekend, and we'll see you on Monday with a new video. Bye now.